Good evening, everyone. Thank you for sharing your valuable time today to attend this session. Today, Creators Garage has arranged the webinar for all you learners where all your unanswered questions will be answered regarding IoT. So make sure to stay till the last of this session. We have acquired many great sources of IoT in one place so that you don't have to wander here and there to uncover them as we at Creator Garage understand the importance of your time. Accordingly, today we are having a great speaker here with us, Mr. Vikrant Thakur, who have incredible work experience in the field. He is currently working in Napino Auto and Electronics and research and development team as an embedded engineer. He primarily takes care of firmware development, hardware design and research and development. He has around more than 3 years of experience in embedded system, R&D and hardware. He is co-founder of the source community called Deeply Embedded, which has around 500 plus folks working in the field of embedded and research. So, with no more delay of your enthusiasm, let's start. Let's invite our guest, Mr. Vikrant Thakur. Over to you, sir.
Thank you, Ria, for such a nice introduction. A warm good evening to everyone. Hope you had a great day, and I hope you still have some sort of energy left as the day is about to uh, end for the work. But I hope you will have some energy. And today session would be more of I will be talking about IoT and interconnected bond between the embedded. So as we know that IoT is something which is currently expanding in a very fast speed. You see, if we talk about IoT, it's around $1.1 trillion market. And when we talk about IoT, it's not just connecting devices, it's more than that. So I will be talking about brief about how IoT is reshaping our lives in B2B sector as well as in B2C, how embedded plays a very important role in the IoT, how the R&D is reshaping in India, that is how the research and development labs are coming up and providing wonderful opportunities for people to work in. And if you want to go in the embedded software or hardware field, how you should get started with and what are the good opportunities that you might have. So I will be sharing my screen. Hope you guys be visible. Uh, so I guess guys, the screen is visible, right? Anyone if can type
Yes.
yes. Yes, yes, okay. Okay, so as I already mentioned about my talk today, I will be talking about the embedded world and how the embedded world is plays a very important role in the IoT. Not only in the IoT in the B2B B2C sector, but also in the IIoT sector, that is industrial IoT and automation. So let's get started. Let's first understand, like, if we not want to know what is like IoT, let's first understand and get into little more deeper insights about what is exactly IoT and how the IoT is reshaping our world. So for today's agenda, I will be talking more about what is IoT. As I already mentioned, the market insights for IoT and embedded. That is like what exactly the market is all about, how the IoT is reshaping, and what is the role of the embedded systems into it. The various verticals in the industrial IoT sector. I would be focusing on the some of the sectors, primarily in the industry use cases. I will be talking about the ODMs and OEM companies that are there in India and how these companies operate to create products, especially in the embedded domain. Then I will more talk about the embedded world as I belong primarily from core embedded field. So I will talk about a little bit about sensor fusion and the embedded world, electronics, a complex world or not, interconnected bond between the IoT and embedded, how the embedded plays an important role in the IoT. Then I will more focus on the research and development that is there in India, how you can reshape a product development. like what are the various stages that are essential for overall product development. I will be talking a brief about it. I will also talk about a little bit about the scope of R&D in India and how the team plan work can help you to develop an exact product that might be required in the market. And at last, if you have any questions, you are free to ask to me. And I hope this session will bring a lot of energy and knowledge to you. And if you feel like if you have any doubts, you just keep it for the end, and I will be there to clarify that. So we will be talking about today more of first layers in the IoT. So like whenever I discuss with someone what is IoT, it's exactly people understand it from like using a connected devices. But that is a term that is really not very clear to everyone. It's not just connected devices, it's just more beyond than that. So we will talk about more about how this IoT really reshapes uh, our lives, and what's the difference between machine to machine, that is two machines combining together and sharing the uh, data, and what difference do we have in IoT, and how this IoT can plays a very important role in upcoming time in industrial sector as well as in our lives. So as we see, according to the Statista, it's 1.12 trillion market in 2025. And if we even reach the half of the market that has been projected by various market analysts, that is very experienced analysts predicts these numbers. So I believe this will be the market that will be more beyond AI market. So that is one major role that we need to think, like the IoT is really evolving very fast. People started back in 1999. There was first development that called as a toaster, first IoT device that was built up, and afterwards there has been a lot of development in this field, and a lot of things are coming up in the industrial IoT sector as well. So if someone asks me what exactly the IoT is, I would say it's an integration of devices over a common network and manipulation of data that is being received by the devices without the intervention of humans. So there are two differences. Like let's suppose if you have two devices that is sharing the data, those two devices cannot be called as IoT devices until and unless one of the devices sensing something or intercepting from the nature. So basically what exactly means is, like suppose you have a device that is there in the surroundings, and it's measuring temperature and humidity, and it's communicating that temperature and humidity to your server, that you call as an IoT device, because that is something that is sensing from a physical world. You need to have some sort of data from the physical world in order to understand what is going on in the physical world and how we can manipulate with that data in upcoming time. So that is one thing that makes the difference between machine to machine, because machine data can be anything. Machine data can be something which is internal, and it can communicate over to one machine by any other communication protocol. Let's suppose if we have two mobiles that is communicating. So those two mobiles cannot be said as IoT devices until unless one of the mobiles is sensing something. It has a device that senses at least like temperature, humidity, pressure, or anything that is there as per the requirement, and then intercepting that data, converting that data and sending over to a connectivity platform and being intercepted from the secondary device. Then I can say, okay, that first device is working as an IoT device. And if I'm intercepting that data, whatever I'm receiving, and converting them into a useful insights, because see, you have the data that you have collected as per the surrounding requirement. Now you need to intercept that data, you need to generate useful insights from it. So it's very important that whatever data you have, you tend to manipulate with that data and provide some useful insights from it. So let's suppose if we have a device that monitors humidity and temperature. You have a device that monitors humidity and temperature and communicates over a GSM platform to the to a main server end, and once you receive that data, you are intercepting how the temperature and humidity over that certain region is behaving as per the environmental conditions. So you can predict temperature and humidity in upcoming time for last 2 years if the condition remains constant. So these kind of analysts platforms you require in order to understand what has been what's the data that you have been receiving is useful for you or not. So first, when we have a IoT device, it must be having a device management platform. Device management platform is basically a platform where you have integration with the physical world. You are sensing some data via sensors or devices and converting that data into a useful insights. Like for example, when I was giving an example of a humidity and a temperature monitoring system, that's the work of the device management platform. That device is actually sensing the data from the sensors and converting the temperature and humidity and sending back to the server. And the connectivity platform is working as a GSM platform, a 4G or a 2G network. Okay, so that's one case scenario where you have to sense the data from the physical world and to interconnect or from the interconnected devices that are there present in the world. Second is the connectivity platform. So how does this connectivity platform works? It's the interlink between the device management platform and the application enabled platform. So this connectivity platform basically does is that senses the data, whatever being intercepted, the data that is there from the device, let's say temperature, humidity, pressure, and it's been sensed by the device, and now it's being need to be sent back to the server or any other platform where you can analyze that data. The connectivity platform plays a very important role, like from which platform you will send the data. Like let's suppose you have sensor nodes placed in the environment. Now those sensor nodes are battery operated sensor nodes. You can't power it from a power supply. That's a requirement because generally IoT devices that are, especially the sensor nodes, are low power, battery low power devices. So in that case, the connectivity platform that you will prefer will be a BLE or ultra wideband. The distance between the two devices, from what device from where you are sending the data to the server, would be less, but it will entirely operate on the BLE, entirely operate on the battery operated system, because BLE consumes comparatively less power. So the point that I wanted to mention here is the connectivity platform plays a very important role. Number one, to interlink the device and the application layer, transfer the data from the device layer to the application layer. It also plays an important role in deciding how much power will be consumed by overall device, because that once you are sending the data, there's a lot of power that might be required in transmission. So if you are able to reduce that power consumption, then you are able to reduce overall power consumption of your device. And that's a really important role in IoT devices. We are entering into the stage where we want devices to be efficient and we want them to consume very less power. For that, connectivity platform plays a very important role, from the device to the application enabled platform, for where you can analyze and sense the data. Which connectivity platform you will prefer? If you're going for Wi-Fi, then like for example, if you're going for Wi-Fi, then you have comparatively more range. But if you're going for BLE, that you comparatively have less range. But in BLE, you can transmit the data in a very low power manner. You all can also operate in sleep mode once the data is not being transmitted by any other device. And once it's been transmitted, the data, the power consumption of that overall device is significantly be less as compared to the device that is transmitting data to the platform via Wi-Fi protocol or by GSM or a GPS protocol. So that's a very important role of a connectivity platform. Which connectivity platform you are preferring as per your requirement? That's one major task that uh, a person needs to decide whether once he's been designing his own IoT product. The third layer comes up is his application enabled platform. Application enabled platform is the one layer that on which a lot of analysts works. The data that has been intercepted by the devices, it's been displayed over that platform, and you need, as a person, as an analyst or as a machine learning enthusiastic or a data scientist, need to analyze how we can generate useful insights from that data, how I can predict that this data is useful for us. Because see, if you need to predict real-time predictions, then you need real-time data. You're already getting the real-time data from the devices. Now the only thing that we require is to analyze how that data is being getting proceed. So that's very important. As an application enabled platform, a person is working on this, mostly a data analyst or a machine learning enthusiastic or a data scientist, to analyze the data and predict the predictions as per the requirements. So this how the IoT device works. First is the device management platform. Second is the connectivity platform. Third is the application enabled platform. Device management platform is the platform where the actual device is intercepting the change in the physical world. It's from either from the sensors or interconnected devices, and the change that is being intercepted is that change is converted into the form of electrical signals, and that device, once it intercepts that, it sends the data to the application enabled platform by the connectivity platform that we have. Connectivity platform can be any platform based upon your requirement. Like if you need the larger distances, then you might go up for NB-IoT or even Wi-Fi or any other platform based upon the distance that you require or the power consumption of your device. So these are the main parameters that you need to analyze while selecting the right connectivity platform for your device. And third is the application enabled platform, where all the data is being intercepted from the IoT device and useful insights is being generated from it. So I guess, hope we might have got some insights how an IoT device works. What are the various layers in the IoT device? How does the embedded engineers are working? So I would again shift back and focus on the layer at with the embedded engineers working, especially the research and development engineers. It's on the device management platform and the connectivity platform. Connectivity platform also contain telecom engineers as well, if you are integrating on a massive scale. But mostly the embedded software and hardware engineers or the research and development engineers who are developing end-to-end product would be working on the device management platform and the connectivity platform, and the researchers who are primarily data scientists or data analysts would be working on the application enabled platform. So these layers combine together to form an IoT device that you see in the market, whether the device is sensing the temperature or humidity or any other parameter that might be there. Like suppose the IoT device is there to analyze the sleep cycle of a driver who is driving the car. So that device also will be having these three layers only integrated to one another in a way that uh, every transmission of the packet would be successful and they can generate some useful insights from it. So let's talk about the verticals in the industrial IoT sector. So here I have more focused on the telematics portion. There are a lot of industrial IoT use cases that we have, like smart manufacturing, smart farming, smart retails. But primarily I wanted to focus on telematics itself because this is a very wider portion, and a lot of growing opportunities are there in the telematics and IoT sector. Earlier in my talks as well, I have discussed a lot of use cases in smart manufacturing, smart retail, and smart farming. That takes a little bit more time to really intercept what those use cases are and how the IoT is useful in those use cases. But today I would be more focusing on the telematics and the IoT, logistics, and the connected cars. So like how if we analyze the use cases in the industrial IoT sector. So one of the pictures that I have posted in my presentation as well is a fleet management system. That fleet management system basically does is, like, you have an IoT device that is connected in your with your OBD port of your machine that has been operating, and it is analyzing the efficiency of the machines, because these machines work in a very harsh environment and performing very rigorous mechanical tasks. So the efficiency of machines need to be analyzed at regular intervals, and those machines where they are getting operated, where the system is getting fully working, these are very important parameters in fleet management systems. So these parameters has been sensed by an IoT device. That IoT device might be responsible to analyze, number one, the efficiency, number two, the engine of the system, number three, the overall pressure over the machine, that is through any pressure or an accelerometer sensor to analyze at which scale that machine is currently present, and send that data over to the cloud-based platform or a server where they can intercept the useful insights from that data. So these are a lot of new coming IoT devices that are there in market to analyze the efficiency of these machines, and if not only the efficiency of the machines but the performance of the workers as well. So how does this performance of the workers really takes a major play in this industries, and how the IoT is really helping to analyze how the workers are currently working. Like, let's take one of the examples in the logistics in the IoT sector. So there's one of the companies who have recently developed a device that analyzes a sleep cycle of the person. So it's a camera fitted device that continuously monitors the driver, and regularly clicks pictures and sends to the cloud based on a server based platform, where they analyze whether the driver has completed his proper sleep cycle or not. If it doesn't have that proper sleep, it gets an alert to the system, and the driver is being asked not to drive the car. Because many a times what happens, especially in the logistics area, is driver tends to doesn't have proper sleep. Due to, it can be due to many reasons. It can be because he's working overtime, or he's not able to get that efficient time, or he might have got that time but he's not taking the proper sleep. So that sleep cycle needs to be efficient enough so that it can reduce accidents in upcoming times. In logistics itself, every 20 cars that have been driven, out of those 20 cars, two have a major accidents. So those type of use cases are very useful to analyze the sleep cycle of a driver, number one, so that the accidents in the roads comparatively reduces to a great extent. Number two, in one of the logistics areas that we work on, and we are currently working in the shipment tracking. That is one of the shipment tracking. How does a shipment is being tracked from one place to another? So there is one of the use case where we have an RFID based shipment tracking. We have an RFID that is placed in the boxes, and those RFIDs being sensed by a master RFID gateway. Whenever it's been away from a range, then it generates an alert identifying that something has happened to the box. Because if the box has been traveling in that same location from one place to another, then the location of that box in that in that specific cubicle of that truck would not change. So if anything happens within that specific range, then it gives an alert indicating that there's something is happening in that box. Number three, one of the use cases that is recently developed by one of the companies to analyze the delivery of the packet is being currently successful or not, is to place an LDR sensor, that is light dependent sensor, in the boxes. So whenever the box opens up, it detects the light, and the detection of the lights indicates that the box has been delivered properly or it's been opened somewhere. So when it's when the device, when the car is moving and reaches to the location, the GPS analyzes the location of the shipment where the shipment needs to be delivered. If the location matches with that location, then it indicates the OK sign that this there that look the shipment needs to be delivered. The shipment has already been delivered. Now when the shipment is being opened, now it indicates with the help of the LDR sensor that is there, that the light dependent sensor that senses the light and indicates that the shipment is being opened by the customer, or if it's not been dispatched yet and it's been opened somewhere within warehouse or stores, then those kind of challenges can be automatically been detected. That if it's been open at the warehouse or store, then it can detect, okay, the shipment has been opened one time as per the sensing of that LDR sensor that is there in the devices, and that device contains a calibrated LDR sensor that detects the light, and as per the light intensity it indicates to the server whether the device whether the packet has been opened or not. One of the use cases again where I talk about in the logistic region is the how the shipment of this packets is the tracking of the shipment of the packets takes place, is where we have the RFID sensors and the GPS module that is there in fitted in the ODB port. So the GPS module of base device that is there uh, intercepts the location of that truck, at every interval, like every 1 minute or 5 minutes. It intercepts and sends the location to the server, and from there where we can analyze where the car is currently present. Number one, it helps to analyze the overall period, how much time it will take to deliver one packet to another location. Number two, it helps to understand whether the driver has not diverted his path, so that the shipment should reach on the correct time, and the driver should analyze the correct path that is needed to in order to deliver the shipment of time. If the driver is not following the correct path, then on the screen itself where the device is being placed, it indicates that you need to take the correct path in order to reach at the right time. So thus reducing the time that is taken from the shipment from one place to another to deliver it, and reducing the main pain point that is there to track your shipment where it is there. Number three, it also helps the customer to understand when the shipment will arrive. So when the shipment is very close to the to his location, a message alert can be sent to that to the customer, indicating that the shipment will be arriving in 5 to 10 minutes, and it really helps to engage with the customer. So that's the one region then where the logistics and IoT in the logistics plays an important role, is to uh, understand the pain point of the customer, to track the package, to track the to track the quantity and the condition of the packet. Number two, to tell the customer when the packet will arrive. So these are the two major use cases and the pain points that has been solved by IoT in the logistic region. Number three is the connected cars in the IoT. See, connected cars and the IoT has been very popular nowadays. And first it was in the automotive domain, but in the automotive region when we used to work, we the company used to keep those parameters to themselves to analyze the efficiency of the car. But now it's been with the help of the IoT, with the help of the connected devices that we have, we can analyze the efficiency and the overall status of the car with the help of the one device that we can put in the car itself. So and one of the use case that I can tell is one of the Ble trackers that are there. So Ble trackers, you can really help the device to get on and off with the help of the Ble. And once it's connected to the ODB port, it can analyze every parameter that is there: the efficiency of the car, the petrol that is left in the car, the interlocking system of the car. You can interlock your car with the help of a Ble mobile, and it can also analyze like what might be minimum parameters that might be required in order for the car to be efficient enough. You can control every system with the help of the BLE or ultra wideband technology that is there in the connected cars in the IoT that is currently being there in the market. So these are the three kind of use cases that are there in the industrial IoT sector, and these are the use cases that actually solve major pain points of the customer. Like it really helps the customer to interlink with the device in a well behaved manner. Number one. Number two, it also helps the customer to solve some of the pain points that is there in the logistics as well as in the telematics and in the connected car solutions. So let's talk about the companies that are generally working on the product development in the electronics manufacturing industry. So these are two type of companies that we have, like OEMs and ODM companies. So it's a very important terms in the industry that is being used. What are OEM companies? What are ODM companies? So I will give a very brief overview, like how does this OEM companies and ODM companies help to operate in the market and producing a good insight. OEM companies are those which develop the product from the scratch. Like let's suppose there is a product required, like Philips. Philips is developing their lightning solutions that are required for the customers in the B2C market that the end customer might be using, or the lightning solutions that might be required by the industry. So those lightning solutions have been developed entirely by the Philips. The everything starting from the design to manufacture to R&D is being done by the company, and it's been licensed out to other partners to manufacture it. So all the R&D that is being done, all the design that is being done by the company is done by the company itself, and all the decisions that are taken in order to modify or change the design is taken by the company itself. That is what we call as a OEMs. So one of the examples of the OEMs that I can give is Apple. Apple in consumer electronics every year releases new phones with new advanced features, and so all the features that is being added by the Apple, or the R&D and the manufacturing that is being taken care by the Apple, it's been done by the Apple itself. No other company is getting involved in the design and the R&D of that product. In fact, only Apple is there, and Apple is deciding which all features that will be included in the product, and what are the features that might be required some more upgradation in upcoming time. So that is what is OEM companies are all about. OEM companies are basically the original equipment manufacturer. They are the one who will design, who will do all the R&D, and who will license out which all the parts of that product needs to be manufactured from the third party. ODMs are basically original design manufacturer. ODMs also do R&D, also do design, but the design and the R&D done by those companies, that is the companies which are working as ODMs, that's original design manufacturer, is not being uh, fully decided by the company itself. It's been decided by the client for whom they are designing the product. Like for example, the Foxconn, one of the Apple's manufacturer of the mobiles, is an ODM based company, because every manufacturing of the Apple mobile that is taking place in that company itself, it's been the instructions and the main use case that is there, it's being provided by the company. No, not by the no, the decision is not taken by the Foxconn. The decision is taken by the Apple itself. So the point of this is that original design manufacturer also do design and R&D for their client products, but everything that has been decided on the design and R&D purpose, it's been told by the client. Client will tell the specification of the product, client will tell what he exactly needs in that product, and then the original design manufacturer will have one-to-one meeting with the customer, and then they will tell whether we can design this product for you or not. It's basically predetermined on the design that is being given by the customer, and customer decides what he needs to design in this product. Any other feature that the company needs to add as an ODM company, he cannot add until unless the customer doesn't give the approval. So that is one challenge in the ODM. Whereas in OEMs is one of the biggest challenges is to understand how we will sell in the market. So you understand the main requirement of the market. Now, once you have done the design, you have done the manufacturing, you have done the R&D, you need to sell that product in the market itself. So how will you marketize that product? That is a very big load on the company, and company needs to find resources and find, it's a very big constraint for the company to sell that product if that requirement of that product becomes down or it's fluctuating. So that's one of the challenge with the OEMs are, but OEMs has one of the greatest advantage is to add the modifications whatever they want in their product, and they also have the control how much they need to manufacture as per the market requirement. So these are the two major advantages as an OEM company have, and one of the disadvantages is to really find someone who can really purchase your product for their own use cases. ODM, where else, doesn't need to do all sort of marketing. It's basically designing the product for the client. Client has a headache to sell that product in the market. So ODM has one of those advantages where he just needs to put minimum resources to design that product for the client, and once that product has been designed for the client, client will pay off the payments, and client has to do the white label and all the marketing and all the certification stuff to sell the product in the market itself. So that's one of the major challenges that is there to sell the market, to sell the product, to sell, have the certification is not being done by the ODMs. It's been done by the client. Unless the client and the ODM have a collaboration, they don't need to take that much headache to sell that product in the market. Once it's been designed for the customer, and once the payment has been paid off by the client side, they can quickly move on to another product, and they can take the another client requirement. Whereas in the OEMs, the product once it's been delivered and manufactured, the all the R&D that might be there, further that might be required in the product depends upon the market requirements, like what exactly the what's the product efficiency, how does that product able to solve the major use cases and challenges that is being faced by the industry or the people. And those R&D and manufacturing and design purposes that might be required, that will be depend on the market insights, the people who might be using those products. So let's we have talked about IoT. We talked about various verticals in the IoT sector, where we talked about logistics and IoT, how the logistics plays a very crucial role, and how the IoT is reshaping the logistics. We also talked about a little bit about the telematics portion and the connected cars. Now we talk about how the sensor fusion and the embedded world takes place, and how the sensors are playing a major role in designing the overall embedded product that will be there in the market. So there is a lot of difference when we talk about a prototype that you might be developing in the colleges, and there's a lot of difference between the product that you design in the industry. The product is entirely designed from the scratch. It's not like a prototype or a POC, something that you do in the college level or a master thesis or a PhD level. That is everything that you design. It's a POC level that you're designing. Later on, if you want to upgrade, you can upgrade it in the product stage. But in the industry, once the POC has been done, there's always a complete cycle of how to convert that POC into the product. And once being the product is being used in the industry, the product will have various challenges, various pain points that a product needs to bear, like for example the environmental conditions, the overall surroundings. Those things really affect the product. So once you are designing the product, once you are selecting the sensors for integrating with your product, you need to really make sure that everything that you are selecting is as per the industry standards, number one. Number two is as per the conditions that the product might bear. So that's one of the major use cases where you have the sensors and the embedded world fusing together, and all the research and development might be required before the designing of the product. So when we talk about sensors, if I talk about very basics about the sensors in the layman terms, is the sensor task of a sensor is to analyze the changes in the physical world and intercept the changes and convert it into electrical quantity. Let's suppose you have a gaseous environment, and the gas in the environment tends to increase or decrease. Then in order to intercept whether that gas is increasing in the environment or decreasing, you need to have sensor that can really analyze that change in that sensor, that can really analyze the change and then convert that change into a electrical quantity, which that electrical quantity really needs to be intercepted by the controller. Then you can start analyzing how the gaseous behavior of the system is taking place. So that's one of the challenges that we have. So once like suppose if I talk about the environment monitoring systems that we developed, one of the products that mostly companies work on in the IoT domain is once you select a sensor specifically for the requirement and the as per the situation, you that sensor needs to bear the environmental conditions. If you are measuring the temperature of the environment, then there is specific range of every temperature sensor you might be using. So you need to use a temperature sensor according to your needs. Like if the temperature is around minus 100 degrees to plus 100 degrees, and it can vary between minus 40 to plus 40. I'm just giving a basic terminologies, the terms. Then you need to have a sensor that can really sense in that range. If your temperature sensor is not able to sense that in that specific range, and if the temperature goes beyond that, then your device fails in that particular specific region. So, and also plus, once you're selecting any sensor for specific measurements, then you also need to have clarity in the cost, because if you are going for a calibrated sensor, efficient sensor, then the cost of the overall product increases. So you need to balance two things. First is uh, the efficiency and the measurement that you might be required. Second is the cost, and overall this balance helps you to identify which sensor or a sensor module I might be using in order to develop my own product for that. So like the one of the use cases that I was discussing, like the gases, where you need to measure the gas and you need to intercept the change in the gases. So the sensor that you might be using, the role of that sensor would be just a material that might be there, and whenever it comes in that gaseous region, the sensitivity of that material tends to change. It might increase or decrease as per the nature of that material from which the sensor is being made. And that sensitivity, that change in the overall impedance of that material tends to generate electrical quantity. Like suppose if you have applied a certain voltage or a certain voltage source across that material, from which the sensor is being developed, and as soon as it comes into the gaseous environment, the sensitivity of that material tends to decrease. The overall current in that loop will tend to increase. So that's how you detect the change in the system. So whenever you are using the sensors are basically those devices or those materials which sensitivity tends to change as per the change in the physical parameters. Those physical parameters can be anything. It can be temperature, it can be humidity, and that material from which that sensor is being made, that material matches with that specific condition that you trying to measure up. So once that sensitivity, the gaseous sensor that I was talking about, the sensitivity of that gaseous material tends to decrease, the overall current tends to increase, the electrical signal tends to increase across that material, and then you can sense via your controller that how much there is a change between the electrical quantity earlier that was measured and the electrical quantity that will be measured afterwards. And that is something that requires a lot of uh, it's not just measuring the signals, it's just the signals that you tend to measure will pass on through many stages. You might be required a filter circuits, you might be required uh, circuits that amplify the amplitude of your signal. Those are the cases where you need to have a little bit of research and development onto the signals that you're receiving from the sensor or a sensor module that you might be using. So that portion I will be more touching up in the next slide. The point of the sensor fusion in the embedded world is to understand how the sensor is being intercepted by the controller, how sensor analyzes the change in the physical parameter and converts that into electrical quantity, which is being sensed by the your microcontroller or a SoC chip, that is the brain of the overall device that you are developing. And then that whatever condition you have put on, like whether you need to control a light based upon the change in the gas, or you need to control a motor, or you need to control the overall housing lights, those everything that you're doing, the actuator that basically is called as termed as an actuator, which converts your electrical signals into a mechanical force. A mechanical force or can be anything. It can be a LED light, it can be a motor, it can be a driving circuit. So anything that you might be driving out, you would be sensing based upon the sensor data that you are sensing. The controller will be intercepting that data, and the controller will be deciding what we will do afterwards, and that depends upon the requirement as per the product that you are developing. So we have nowadays what we tend to have is not just one sensor. We have tend to have a lot of sensor modules to analyze all the data being there in the overall big chambers or big rooms. So in order to analyze those datas, we need to have a sensor module, and those sensor modules tend to operate at a very low power connectivity platform, because those sensor modules are designed in a specific way that they can operate on the battery operated system for 1 or 2 years, or maybe more beyond than that. So those low power connectivity platforms, if I talk about, they are very limited in the market. Mostly you have connectivity platforms which tend to send information over larger distances, but they consume a very large power. They To operate those connectivity platforms like Wi-Fi, GSM, GPS, or 4G, 5G, you need to have a lot of power with your device in order to operate those modules or the connectivity platform that you might be requiring. So for that, that purpose doesn't fulfill if you need your device to be operating at a battery level. So if you need your device to operate at a battery level, which tend to have a less distance to travel the information, but it tends to consume very less power, you need to go for the BLE or ultra wideband or WLAN or NFC and Zigbee. So these are the low power connectivity platforms that I mentioned. One of the BLE power ratings that I can tell about is the Nordic Semiconductor module. This module is being very frequently used in the industry. If you go for the Apple AirTag as well, that is released by the Apple recently, those modules also contain this NRF Nordic Semiconductor chipsets. These BLE modules are very low power and tend to use in the sensor module a lot, where you need to transmit information over shorter distances and you need your device to consume very less power. In sleep mode, if you can see, these are the technical equations that I have taken from a uh, official data sheet that is approximately less than 1000 UA, and if they are maximum, they are transmitting the packet, they tend to consume around 80 to 100 milliamps. But in one case scenario, number one, the case would be the distance, the overall BLE to which it can transmit the distance not more than 100 meters. Number two, the data packets being sent at a specific interval tends to decrease if you are operating with a low power connectivity platform, because they tend to consume low power. So they, the packets that you can send at one interval, or you can say at one microsecond or a millisecond, tend to decrease. And those, in this case scenarios, you need to really cope up with these kind of cases. But if you analyze these sensor modules, they do not have that much amount of data to be sent at regular intervals. The data packets are quite small enough, so you can easily send those data packets. You don't need to send large data packets, or even if you're sending the large data packets, there are certain algorithms with the help of which you can reduce the format of the data packets and you can send it over to the BLE platform. So these were the kind of information that we have on the low power connectivity platform. One of the connectivity platforms that are frequently used in the industry is the ultra wideband. Ultra wideband is nowadays, if you see the case of the Apple AirTag as well, Apple AirTag use the ultra wideband. It tends to consume little more power than BLE but less than Wi-Fi. That's one of the major advantage of an ultra wideband. And second advantage is the precise position of while using the ultra wideband as a communication protocol, as a connectivity platform. One case is to, if you really want to have a device with the precise accuracy and precise positioning, then ultra wideband is one of the bands at which you can work on. And these bandwidths doesn't have that very large frequency. It doesn't work on 2.4 gigahertz. They tend to work on a very less frequency gigahertz. They tend to transmit less data over a period of time, but they significantly consume less power and they're more accurate as compared to BLE and Wi-Fi. This is one of the spectrum that I have shared. This is one of the pics that has been taken from an uh, research paper analyst. So this is the ultra wideband frequency, and this is the frequency scale at which it's working. This is the power spectrum density, how much power is being consumed. This is the power consumption by the ultra wideband connectivity platform. If you see Wi-Fi tends to consume a lot of power. GPS tends to consume comparatively a lot of power, but on the same end, if you see GPS, Wi-Fi tends to transmit the data over the longer distances. Number one. Number two, it can transmit more packets. But you need to design the product as per your requirement, as per your uh, costing, and as per your specification. If you need a device that operates on that you need to be a battery operated, that doesn't have that much amount of data to be transmitted, and you need kind of a sensor node system where you can make specifically make an interchange of nodes at every 100 to 200 meters, then you can go with the low power connectivity platforms like BLE, ultra wideband, even Zigbee. Zigbee is very much used protocol in the home automation systems. NFC, on the other hand, is very much frequently used in the attendance management systems, where you need to communicate over 1 meter to 10 centimeter. The power consumption of the NFC as compared to BLE and ultra wideband significantly reduces to a great extent. And some of the NFC tags that you might be using, they are powered from another source when the source comes up very close to it. So these are the quite good examples of the connectivity platforms when we are selecting to transmit the data from the device to the application enabled platform, where the distances is not quite large enough, and you need the devices to operate at a battery so that you can transmit significant packets that are required, and you can really operate them at a very low power, provided the packets are very small and packets are transmitting at a very low distances. No, so like here's an overview of how things are working out. So let's suppose if I take this is a very good example for all the people who might be want to enter into the embedded field or embedded software or embedded hardware engineering field. So how does we encapsulate to design a product? How we take a one step? Let's suppose if you need to analyze the humidity. So we have one sensor that is there to analyze the humidity. As I already talked about how the sensor works, sensors basically works to analyze the change in the physical environment and convert them into electrical quantity. And how does that change tends to take place? It's a change in the sensitivity of that material that you might be using, from which the sensor is being designed. So if you are measuring the humidity of the environment, the material that might be used will tend to have changes in the sensitivity of that material, so that the overall the electrical signal that is might be passing with the material tends to change once the humidity increases or decreases. So this is one sensor that we have. This actually the picture is for the temperature sensor, but I'm taking an example of for temperature plus humidity that you tend to have when you select sensors or sensor modules while measuring the environmental conditions such as temperature or humidity. So like you have an when analog sensor, that analog sensor is basically changes the intercepts the change of the temperature with the change in the analog signal, and that analog signal is varying in the nature. As we know, all the people, it's not like a digital signal. It's not in the form of reference voltage. In digital signal, whenever we are designing any digital signal, we tend to have a reference voltage based upon which we can analyze whether the signal will be 1 or 0. But here the signal intercepts and changes as per the time, and when the signal is changing as per the time, you need to convert that signal into a digital format so that your controller intercepts that signal, the MCU or the SoC chipset that you might be using. So once you are selecting the right conversion, you need to have something, an interface that can convert your analog signals to digital signals. For that, you have an analog to digital converter. If your controller doesn't support analog to digital converter, like let's suppose if I go for an FPGA, that is field programmable gate arrays, those doesn't have an ADC. So you need to have an external ADC interface with your FPGA. But if you are selecting an SoC and MCU nowadays, which are mostly ARM Cortex M series or SoC chipsets that have their own architecture, they tend to have internal ADCs, and those internal ADCs needs to be configured when you are measuring the analog signal from a sensor. and those ADCs that you might be working with, they work on two parameters mainly: the sampling and the resolution. Sampling is basically at what frequency you're transferring your packets, and the resolution is basically the at what resolution, at what minimum voltage your sensor can intercept. That depends upon the V reference of the voltage. So those two parameters are the major parameters that you are selecting when you are working with an ADC. And as per the resolution of your ADC increase, your number of bits of the ADC also increases. So if anyone have worked on ADCs, they can tend to catch up. Like, suppose if you have an 8-bit ADC, 10-bit ADC, 12-bit ADC, those bit tend to increase. Once they tend to increase, the resolution of your measurement also will increase. You can precisely intercept a signal that is of a minimum voltage once you are converting that signal from an analog signal to a digital signal. And once you convert that analog signal to a digital signal and being intercepted by your controller, then you can send that data over to your cloud based platform, or or any other platform that you might require based upon the connectivity interface that you might be selecting. Okay. Now you have a sensor modules. Sensor modules are a little different from sensors, but they are work in the similar fashion as what I have predicted in the first picture. Sensor modules basically are those which already have an internal MCU with an inbuilt ADC. So the tedious task that you were doing with with a sensor that only had a material and at only had a semiconductor material, which tend to analyze the change to which a voltage that you might apply, and you get the results. Here you are already getting the digital format of the data from a sensor module. So the sensor module encapsulate all these things that I talked just 5 minutes before. And those sensor modules that you might be using, they communicate over a serial interface. The serial interface can be anything, like it can be an SPI, it can be a UART, it can be I2C, based upon the standard serial interfaces that are there in market. Mostly, if you are integrating a sensor module, then it communicates over an I2C protocol. And all these protocols that I'm mentioning, these are the very standard protocols that still used in the industry, like CAN protocol, I2C, SPI, UART, and some of the protocols you might be studying in the college or in the master levels as well. What we do in the industry is to apply in the at the industry level, and in and these, once we are integrating these protocols at which the data is being transmitted, these tend to work at a very high level of scales. Like you will analyze virtually as well as physically how these protocols are communicating data. And the most important parameters that these communication protocols tend to have is the data rate. Data rate means that at what rate you are sending the data, what are the number of bits you are sending at per rate. The frequency is the at what frequency, at what speed you are sending the data. Bit and the baud rate is number of bits that you send per second, or the baud rate number of bits that you are per second sending, or whether the data is being a synchronous pattern or an asynchronous pattern. If it's a synchronous pattern, then it follows a data frame rate. Even if it's an asynchronous pattern, it follows a data frame rate, but the clock would not be the element to integrate both the devices, the sensor module and the your controller. Means that there might not be a common clock that might be required in order to synchronize both of them. Pattern would be there, but the clock would not be there. So if there is a synchronous pattern, clock must be there in order to synchronize both of them, meaning that once you're communicating with that sensor module, they are working on a similar clock. If you're working on an asynchronous pattern, then you need to be very sure that the clock is not working. The only thing that you can correlate is the baud rate or the bit rate that you might be working on. So this is a very basic example of how you integrate a sensor to your controller. And in industry, we tend to work on a very massive scale. We work on sampling, we work on resolutions, we tend to make that product efficient. In the colleges that you do with the controllers that you work with, those are basically the POCs that you might be working with. But here we need to have when you're designing any product in the industry, you tend to work on every parameters, like what is the resolution of the values, what is the exact measurements that you are measuring, as per the environmental condition the temperature is changing or not, as per the rise and fall of the temperature frequently, whether the sensor has been able to intercept that change or not. Based upon that, there is a graphical representation that we tend to make, and then we tend to decide which sensor would be accurate for a specific purpose. There are a lot of sensors being manufactured by semiconductor companies, and based upon the material, the semiconductor materials composition that they might be using to design that sensor, the efficiency of that sensor tends to decrease or increase, and this also varies with the cost. So everything you need to place, the efficiency of the sensor, the requirement, as well as the cost that you have, these both the three parameters should come in line in order to decide which sensor module or sensor you might be taking in order to integrate with your controller. Same goes with the connectivity platform as well. Which connectivity platform you will select, whether you need to send the data over longer distances. If you're sending the data over longer distances, then you need to analyze whole power management budget of your device, how much power your device will consume. And if you are tend to transmit the data over shorter distances and the packets are short, then you need to select a interface that consumes comparatively very low power. So these are the parameters you need to analyze once you are starting entering into from your POC to your product stage. And I will talk more about these details in my one of my next slides that I will be presenting. So today, I would also like to very much focus a little bit about how the electronics is being called as a complex world. So when we talk about electronics, it's not like open source as such. When you see the softwares and the people who are working on the full stack, or people who are a data analyst or data scientist, they more tend to be more comfortable with those all things, seeking that a lot of things are open source and widely available, as compared to electronics, which basically requires both skills, as well as you might, if you're developing a embedded product, you might be requiring embedded hardware skills as well. You also require embedded software skills as well, the firmware development skills, which I will be talking later in my slides. So people, when we talk about electronics, they tend to say that it's from a very complex world. It's a little complex world because a little bit physics is involved, mathematics is involved, and hardware is also involved, which people tend not to go into those fields. But to be really honest, what I've seen the change is the change has been significantly rising up. Now people tend to work a lot of on open source things, like you tend to, like if you see a case in the Arduino itself, Arduino somehow revolutionized the electronic industry. Nowadays, if you need to integrate a sensor, you just need to plug in an Arduino, plug in a sensor. You might end up finding a library for that specific sensor, and you can integrate and you can get the results whether the sensor is working or not. So this how the open source hardware has revolutionized the industry. Somehow you don't need to even think of reading the data sheets of the ICs to integrate with the Arduino Uno. You just need to have a library and you can get the data and analyze whether how the data has been intercepted. These changes are being tend to happen because things are becoming more open source. Now people tend to work a lot on open source um, projects, and they tend to release those projects, based upon which the development on those projects have tend to rise significantly. If you see the open source from last over a decade, this has been constantly very high development in open source. And if you need to learn embedded, then the embedded has now become really easy with the help of the open source designs that we have, the open source controller boards that we have. Like, let's suppose if I talk about one of the boards, that is Bigambone. Black Bigambone back is one of the most powerful ARM Cortex A series open source boards that you have in the market. You can buy it around 4 to 5 thousands, and you can start the development. If you want to work on the Linux OS, you can port the Linux OS in the Bigambone Black, and it contains a very good RAM on which you can tend to integrate your devices as well. So it's a very good learning for someone who tends to work on Linux and wants to work on the A series controllers. Second is the Onyx Max. This recently released controller board, that is there in the market, and it's quite open source. It's being based on the MX233 ARM processor, and this also runs on a Linux OS. If you need to work on Linux OS and tend to acknowledge like how the porting of the OS takes place, how the OS tends to play a major role in embedded software field, whether you are working with the FreeRTOS or whether you are working with the whole OS that you might be porting up, then this board is very useful, and it comes with a comparatively cost that is there in the range. Arduino Uno, as you all might have worked on, this board is extremely popular in a easy to use microcontroller. It's an 8-bit microcontroller where you have a microcontroller development board. It's Atmega 328P based microcontroller development board. You have analog pins, digital pins. You can port your code easily with the USB interface as well, because it contains an inbuilt bootloader. So you can easily port your code, and you don't find any difficulty while like writing any code for Uno, because you tend to get a lot of libraries open source when you are interfacing anything with the Uno base. It contain the Arduino IDE is a Java based IDE, and mostly the libraries that you port, it's based on the recombination of C++. So mostly C++ tends to play a major role in while designing the Arduino Uno libraries. But I would recommend, especially to students who are there, even if you're going for Arduino Uno for your development in your college time, tend to understand what you guys are doing. Like let's suppose if you're integrating any if you're making any attendance system, and you have an sensor that matches the fingerprint of your that uh, uh, understand the fingerprint of your that stores the fingerprint of all the people who are there in the class, and then it intercepts whether the person has entered in the class or not with the help of the fingerprint. Try to understand how that sensor module is working, which interface it is using, how that library has been developed in order to retrieve data from that module, whether it's a module or a sensor that is sending the data in the packets. So how the you are able to intercept the data when it's a sensor module, or if it's sending the data, if it's not a module, if it's a proper sensor, then how you are intercepting that data and converting that into useful packets to understand the areas where the fingerprint matching is taking place. So these kind of cases you tend to understand, not just using Arduino Uno, but any other controller. Whenever you are using those controller, tend to understand what you are designing, number one. Number two, when you are designing, you need to make sure that you are clear with each and every aspect. Even if you are porting any library from outside, then you need to understand how that library has been built, because in industry you don't have anything open source. You need to write everything from scratch. We don't use Arduino Uno in our products, because Uno is works on an 8-bit controller. We have cases where we need to have uh, higher speeds, and we need to process the data very fast, and we tend to use controllers which are ARM based controllers, which are ARM based series, that is 32-bit based controllers or a 16-bit controllers, or even we might be working on controllers which have A series architecture, that is ARM A series. So it depends upon how you integrate, but the basics that you can wrap up very easily is to understand whatever step that you are taking up and how the controller is working. So that's very important for an hobbyist or anyone who wants to enter into the embedded field. The fourth is the Arduino Duo. Is one of the Arduino boards been recently released. The one of the more advantages of the Arduino Duo is like it's a ARM-based processor, so it have the capabilities and a lot of power to integrate a lot of things at a singular time, where else in 8-bit controller you might be having less GPIOs, and the processing of the data would be comparatively on a slighter lower side as compared to a 32-bit controller. So these are the cases where you have tend to have over stronghold if you are going for Arduino Duo. Then you have TI MSP 430. This is a very affordable kit, microcontroller development kit. I everyone recommend everyone, if you want to enter into research development, or if you want to work in the embedded software field or a hardware field, you must have this board. This is a TI microcontroller based board. If you want to work on the TI controllers, then this is a very useful board to get started with. So these are the kind of open source boards. I've just listed out 5 to 6 boards based upon my understanding and the working that I have done. But there are a lot of boards that I also have as well as with me because I'm also an hobbyist. I've worked with a lot of projects, and later I work on products as well. In colleges, I used to work with a lot of projects, so I used to have a lot of boards. So, but I didn't mention them because some of them are not open source still yet. But these are the some of the boards which you can purchase and you can start tinkering with. And believe me, as electronics is becoming more open source, electronics has tend to become very easy for students. People now can learn embedded in their homes itself. The only thing that they require is the passion, and what they're doing is they need to have the proper understanding. Even if they can have a mentor who can guide them through this process, then it would be very useful, because once you get into work with the R&D team, then you really get to work with real products that this deliver into the market. It's very different from people who are working in the IT fields, because when you work in the R&D domain, then you can actually see which product that you might be working on is actually delivered and into the market, and it's working in the real case scenarios. And you will also feel something which many of the people might not be feel in that way, that you can design the end-to-end product if you have the knowledge of both embedded software as well as embedded hardware. So that can only happen if you start working on start developing your skills. And if you feel like if you have stuck somewhere, you can always reach out to me. I will definitely share how you can reach out to me via social media platforms. So, like this is the last one of the last slides that I wanted to discuss. Is I would be a little bit talking about product development in the electronics manufacturing industry, how the product development takes place. So, like let's suppose if you have an idea, you first evaluate that idea. If you have an idea of um, analyzing the workbench, like you need to develop a smart workbench where you need to intercept how much temperature is there. Smart workbench means like people who are sitting in the offices. So what happens is they tend to set the temperature of the ACs as per their requirements. But what will happen if we do not need to take this pain point on ourselves? And AC can automatically adjust as per the number of people and the temperature of every body. The average temperature it can measure, average temperature it can maintain, thus by reducing the electricity consumption, number one. Number two, it also reduces the pain point of people who are sitting in the offices and switching on and off the ACs to adjust the temperatures. So that is one of the use case. If I need to develop, then how would I work from concept to the product? That is one way to is to evaluate. Like suppose I have an idea, I need to develop a smart workbench for people who are working in the offices, and the work of that is to analyze the number of people in the offices. Number one, to analyze the temperature, overall temperature of that area, and to control the cooling of the AC. For that, I first have a concept in my mind. Once I have the concept, I have to do the project analysis. Like every project analysis means the internal documents, not only from the embedded software side, from the embedded hardware side itself. Like if we consider embedded hardware side, what are the key hardware portions that might be required? Let's like suppose if I'm analyzing the overall temperature of the area, then I need to have a temperature sensor integrated with my MCU. And if I'm counting the number of people sitting in the room, then I need to have something which can tell me about the number of count. Then I can have something which measures with my human radiations, because whenever a human is coming, or any other person is coming, some sort of heat is being released. So if that heat is being intercepted, and those radiations can be intercepted in order to analyze the how many human beings are sitting in that room, then I can really predict and control the cooling of the AC. So I need a circuitry, number one, to analyze the temperature, number two, to intercept the number of people that is sitting in the room via human radiations. For that, I might be using a passive infrared sensor or a sensor which measures the human radiation, and based upon that I need to develop an algorithm which can analyze the number of people as per the human radiations, and need to project graphically how the variation of human radiations are affecting the number of people sitting in the room. And based upon that, I need to develop an algorithm that I might be writing in the firmware development, firmware that I will be burning on my controller. And this is the one part of the circuitry that I need to develop. I will have a one documentation of that circuitry. Number two is the power consumption, overall power consumption that is there. I need to analyze the power consumption in order to select the right source for my product, whether I need to power it through a battery, whether I can power it via battery, or I need a external source. Like let's suppose if a product needs to be have a current rating of 1.2 amperes, then I can't make that device as a battery operated system. I need to give it a power source that can deliver 1.2 amperes, because 1.2 amperes is quite a large current rating as per the 5 volt or a 12 volt range. Let's suppose if I calculate the power management and I'm able to reduce the current ratings of that device from 1.2 to 330 milliamps, or 400, or let's suppose to 600, then I can operate it on a battery. And I can select a battery based upon the requirement, like how many days it should operate based upon the charging of the battery that I will be using in that. So the overall idea is to analyze, is to design whether you need to whether when you are developing a power supply, whether it's an SMPS power supply or a linear mode switch regulator power supply, how you will design that power supply, whether it will work on the aspect of consuming low power, if you need to design product that consume low power, or you need a power source that can deliver significant amount of power. That is their one circuitry. And other than that, there are also some documents that will be there from the software side as well, to analyze the how the software architecture will take place, whether you need to write at the bare metal, or you need to write at the middleware, or you need to write at the application layer, how those layers will interlink to one another. So these are the project analysis, and that project analysis has been done in the internal documentation that you do. Each and everything needs to be documented before proceeding further to the actual development. Then it comes with the hardware design. The hardware design covers two aspects. First is the POC, the POC that you might be doing, that is a proof of concept, whatever you have analyzed, like whether it should be battery operated or should be powered up with the source, or whether I will be able to sense the number of people with the algorithm that I am developing, or I will be able to analyze the temperature of the overall region, and whether I will be able to transmit the data over a BLE or Wi-Fi or any other protocol that you might be selecting as a connectivity platform to sense the data over the application layer. You will develop a POC for that. That is proof of concept that we mostly work on in the colleges that we develop. So that POC that you are developing should have those aspects. Then once the POC has been done, we analyze whether whatever the idea and the evaluation that we were doing was correct. Then we start doing the hardware design from the scratch. The hardware design would be related to the first the schematic design. The schematic design will include everything that I was discussing. Let's suppose the example that I took earlier to explain how the things will move on. So the schematic will include everything, and the schematic will not only just include the overall circuitry of that device. It will also include the BOM optimization, that is what will be the number of materials that you are using in that device, what will be actual power ratings of all the devices, or what are the chips that you are using, what are the controllers that you're using, whether you are using a BLE base low power chip controller, or whether you are using an SoC chipset, or whether you're just using an MCU base as per your requirement. So these are the hardware design techniques that you might be using, based from the schematic to the to your PCB, then to your Gerber, that is the final file that you might be giving up. Then before that, you start also working on the firmware development aspects. Once the POC has been done, now you will start writing firmware for each and every aspect in a more detailed perspective, like how the software development will start take this. So whenever you start with the POC, and once the POC has been done, you start working on the hardware design soon after, and the software development starts on that. So that's a major challenge. Like until unless the hardware is not been developed, how will you develop the software for that particular hardware? For that, we tend to have the evaluation kits from the various companies that's been developed. Like let's suppose if I using a controller from a TI, Texas Instrument controller, then I tend to have an evaluation kit from the Texas Instrument and start working with the firmware development by integrating all the modules that I might be required in that hardware design. Sooner or later, the hardware design will be completed and it will be gone for the manufacturing. And once it returns from the manufacturing, I can test that software development on my real-time boards. Then you require the certification. So when you are releasing before mass scale manufacturing, you need to have certifications of every hardware design you develop. Like there are some EMI certifications. Like if your devices tend to measure number of people as per the human radiation, then one certification might be required, which can authenticate that the product is valuable and can be used in the industry. And certification is one of the major pain points that you need to work that you need to do, because until your product is not certified, you cannot use it in the industry. So that is one certification that you might be required. Then once the whole certification and once the whole product has been developed, you test it in the various use cases, like in the chambers or in various verticals, and in areas where the human radiation even crosses the level of the measuring of the sensor or the temperatures. You tend to increase the temperature. You tend to have a lot of testings over the product based upon the key elements that are there in the product. What are the key element measuring features that are there? Like suppose if there's a temperature monitoring or or the number of people come, then you tend to increase that beyond the range of the sensor to analyze whether it can behave properly or not to that case scenario. So that are cases where we do certain type of testings that are there. There are also some testings which are inter circuit testings to measure voltages and currents at specific test points that are there. And those type of testings are also done before mass manufacturing. Then once the testing is being developed and all the changes that was required in the hardware design at the software level was completed, then mass manufacturing is handed over. That is where the production comes into picture, where you need to produce that product into massive scales based upon the client requirement or based upon the requirement as per the market. It can be an OEM based company or an ODM based company. Both of the companies have the same kind of fundamentals in order to design the product, and these are the key elements where you tend to work with the how the product development takes place. So, like, let's suppose we have a we discuss about the product development. We discuss about IoT and how sensor fusion and embedded takes place. Now, let's work on like what is the scope of the R&D in India. So, all these end-to-end product development skill sets that we require. One of the major skill sets that required in the product development is the research and development, and India tends to lag behind in research and development as compared to other countries. If we say we produce large number of engineers every year, then the number of engineers that we are producing is not as per the specific quality and the demand of the engineering team. So that is one problem that we have faced. But now the Indian engineering divisions has tend to invest a lot of money into R&D sectors, especially if you see an evaluation like from 20 to 2.3 billions in 2016, it has raised to 38 billions. Now India accounts for like 40% of the total budgets being spent by the US. So if US is spending around $34 billion on its engineering and R&D team, now India tends to spend around $13.4 billion. And the investments in the R&D and the electronic manufacturing tend to increase even further as per the Make in India campaign is being run by the government. And as we tend to uh, less demand on the Chinese products, we tend to move on to build our own products. The investments in R&D and the electronics manufacturing will surely increase, and it becomes a great opportunity for people who want to work as in the field as an embedded hardware engineer and embedded software engineer. As the scope has been rising, the job opportunities tends to increase in this sector. What are the like let's when we talk about the job opportunities, then we also need to focus on the skill sets that might be required. So one of the skill sets that might be required is the team working skills, like how you work in a team, because you are not the only person who might be developing the product. You need to coordinate with the hardware team as well. You not need to coordinate with the testing team. You need to coordinate with the firmware team as well. So team work skills is very important in those case areas. Interpersonal and technical skills are the one of the crucial skills that you might be required in R&D, because if you don't have those specific technical skills, and you not be able to do proper R&D required for the product development. Interpersonal skills are required in order to have proper communication between the teams, so that you can resolve these issues in minimum time. So thank you from my end today. I hope this talk will be useful for you guys. My LinkedIn account is already there if you need to follow up. I mostly write a lot of blogs regarding technical aspects. Here I didn't catch up too much technical. I just catched up the overview of how the technical things work up. And hope if you guys are interested, you can reach out to me via my LinkedIn account or my Twitter account. And this is my community's Telegram group if you want to join. I will be soon sharing we are building on website, and we are also working on a lot of open source projects. So if you are really interested, you can join the community and contribute to it. And believe me, we have a people of around 500 people. So if anyone is interested in working in embedded domain, then it's a very useful community for people who wants to get started with. Thank you so much, North Camp University, and I would like to thank Vasu and Ria for giving me an opportunity to share my knowledge. And I hope this knowledge would be fruitful for you people in upcoming time. Thank you so much.
Thank you, sir. And I hope most of your doubts must have been cleared by now. But still, if any one of you have any kind of queries, you all are free to ask. Sir,
Sir,
there is one query in the chat box. Can
Yeah,
you
yeah.
please look after it?
Okay.
sir, if you wanted to join your project, an open source project, from where we have to contact you? From which
Okay.
source we have seen
So
this?
basically, I share some of my projects on GitHub, and the GitHub link is there in my LinkedIn account. So you guys can refer that GitHub repositories. You can pull up the repositories, and uh, whatever I'm posting up, I post with the proper documentation. So if you have any doubts, you can post me up on the GitHub or LinkedIn or Twitter, or if you want to join, you just pull up the repository and you start the development on whatever projects that I might be working on. And believe me, like GitHub is already open source, and if you start working, then we can both collaborate and release good projects. So from I've not specifically released my hardware designs till now. I mostly work on the software aspect. So I've released a lot of software projects. So like one of the projects that I open source some time back was for an RT thread OS. That is one of the OS being developed by the uh, open source Chinese community. They wanted to run those OS and wanted to see how the efficiency of that OS is comparatively as compared to the free RTOS. So that is one of the open source projects that I've recently released. There are some of the projects more as well. You can look up my GitHub account, and you can start with the development. In fact, there are some products on which I've worked as an open source enthusiastic. So those codes are also there. So if you want to refer those repositories, you can easily refer them as well. And if you really want to work in open source projects, then our community, there are a lot of people who in our community as well who are working on those. So you can join our community via Telegram channel. We also have one WhatsApp group which is more active, but the problem is the WhatsApp group is already filled up. So sorry for that. But in Telegram, people are tend to be very active, so you can join the Telegram group.
So actually, we just need the link for the Telegram and
Yeah,
for your
I
GitHub
have.
account.
Yeah, I have those links in my presentation. I will share those links to the organizers, and as well as the
Yeah,
presentation in the PDF format, so you guys can join.
yeah, Mr. Vikrant, we can share your all the related, links and all those things that would be required for the audience in our group page, and we can give the link here. It's one
Yeah,
link, and then all the things will be shared there.
Yeah, definitely.
Thank you.
Yeah.
Any other doubts if anyone have?
Yes, sir. Harshit Kapoor has a doubt in the chat box.
Rajat
His
Kapoor.
question
Okay.
is, can Firebase Cloud be used for commercial purposes?
Okay, so Firebase are current. There are some cases where Firebase is being used, but to be honestly speaking, Firebase is not that much used in the industry. But it's a very good platform to get started with. So if you're working with the Firebase, then I would not recommend you to switch from any other platform. You explore the Firebase, then you tend to explore more platforms for further development. Um, Firebase is in some cases in some IoT products is being used, but not that frequently used. So people mostly worked on cloud or service-based platform because the devices that they are deploying, it's not being fully supported by the Firebase system. So Firebase are not that frequently used in the industry, but yes, it's a good platform to get started with. Any other doubts?
If anyone have any kind of doubt, either they can raise their hand or write it in the chat box. But due to shortage of time, we will not be able to answer all the questions. Sorry. Now, thank you, sir, for sparing your beneficial time for this great session. We are looking forward to have many more such webinars with you.
Yeah, thank you so much, Ria, and thank you so much, Vasu, for giving me opportunity to share my knowledge. And I hope this session would be useful for you guys. I will share my presentation to you guys, and you can refer them. And if you have any doubts that come up in upcoming time, you can always reach out to me via social media platforms. Thank you.
Thank you, sir.
Yeah, thank you, sir.
Now,
And I've shared a link in the group chat, so all of you can get in there, and we'll share the all the necessary details related to sir very soon in that group
Acha,
itself.
this is one question I guess has been asked: how to save the data from an IoT device when there's a power cut and it's keep running? Save the data from an IoT device. See, if there is a power cut, then obviously device won't work. So I don't got the question properly. How to save the data from an IoT device when there is a power cut and it's keep running? Uh, if you can elaborate this question, I was just checking up the chat window. Holy. You- Hello. If this question is not there, that's okay. The answer would be like for running up an IoT device, whichever you are running, you constantly need a power source for that. So if your power is cut out, your device won't be working. So there's no point in saving the data. If you rechange the question, I think you wanted to ask is like how you can cut the power and you can transmit the same amount of data. See, so like as per the power consumptions that your connectivity module will consume, the data rates or the bit rates and the frequency at which the device is working tends to interlink. So you need to select a device that can send that same amount of data, maybe taking more approximate time to reduce the power consumption. Like if in earlier few time back I talked about the BLE modules that operate. Those BLE modules tend to uh, share short packets of data, but it works on a battery operated life, so it operates for a significant period of time, thus saving your power consumption of the device. And the data that you need to transmit, you can transmit in the packets. It might take a little more time, but you can significantly transmit packets if the range is constant. So that's how you can really save up the power consumption, as well as you can also transmit the amount of data that you might required to transfer. Okay. I don't think,
Thank you, sir.
yeah, I don't think anyone have any doubts. So thank you so much. Uh, Thanks for everyone for their time.
Thank you, sir.
Thank you. Bye.
Now we have some announcements for you, so I would like to invite Vasu to continue. Vasu, you can take over now.
Oh, okay. Hello everyone. Just please make sure that my screen is visible or not. Is it visible, guys?
Yes, Vasu, it is visible.
Okay. So, hello everybody. Myself Vasu Singh, technical leads at the Creators Garage. I hope you all liked the webinar. Here, I would not waste much your time. As you all know, our event is not complete without goodies. Therefore, as promised, it's the time to reveal a surprise. Today, I have two announcements for you as well as a special message which will help you in the future projects as well. The first announcement is we are releasing a fresh list of more than 200 plus recruiters with their respective IDs, names, and connections. Yes, you heard it right. 200 plus at a single stage. It will help you in finding various internships with ease. The second announcement is we are giving you a doc flooded of various links containing ideas and even the information about various mini and major projects, as well as tech related blogs, popular social media handles to learn about various basic and small innovations, and some best sources for learning Raspberry Pi and Arduino as well. In few moments after the session, you will all receive these goodies in the WhatsApp group only. So, last but not the least, guys, the major announcement for the day is our community will now be open for you all. You can make projects, interact with other peoples, and clear your doubts. We will send you the mail soon. You can now see the YouTube links to our Creators Garage YouTube channel. We have recently made this channel. Make sure you subscribe to it and share it. We will be posting various exciting things related to programming, robotics, etc. on our channel. Let's learn together and grow together. In this end, I would like to say to all of you, now it's the time to take risks. This is the time to get bold. You won't regret. If something is important enough, you should try it even if the probable outcome is failure. With this, I will say goodbye to all of you and thanks for connecting to the Creators Garage.
Sir, how to join the club?
The links will be shared with you through mails.
Okay,
Just
okay.
stay connected with us.
So in the club, you can share the project about the projects, right?
Yes.
Okay, sir.
A feedback form is being shared with you all in the chat box. And remember, your matters to us a lot. So please don't forget to fill the form, and your attendance will be marked there.
So once again, thank you everyone for joining with us. It's really great to see you all with us.